this video, we're going to look a little bit more about bonding and also what effect that has on the behavior of some of the molecules that have different kinds of bonds. Just a reminder that the two kinds of bonds are ionic, which involve the complete transfer of electrons from one atom to another, creating ions, and then the two ions are held together by opposites attracting, electrostatic attraction. And then the other possibility is covalent bonding, where the electrons are shared between two atoms. If it's purely covalent, they're purely equally shared, and that only happens when two things have exactly the same electronegativity, like chlorine with itself, for example, or hydrogen with itself. We might refer to that as a non-polar covalent or a purely covalent bond. And otherwise, it would be a polar covalent bond because they are unequally shared, because one has a higher electronegativity value and pulls the electrons closer to it than the other. So we can think of covalent as at one end of the spectrum, ionic is at the other end of the spectrum, and polar covalent is in between. These are not hard and fast little categories, except for covalent, where it has to be an electronegativity difference of 0. And there is no purely ionic. It's going to be really, what it is just really, really polar covalent. So let's look a little bit about polar covalent, what effect that has on the shape, or not on the shape, but on the behavior of a couple of atoms that have been bonded together. Remember, that means that one has a higher electronegativity than the other, which means that, it is illustrated in this picture, if it's ionic, in theory anyway, there are two completely separate ions. If it's a non-polar covalent, it is just one molecule, exactly nicely shaped, lozenge shaped, with two atoms that are sharing electrons. But in reality, if it's polar covalent, it's some kind of blobby thing here where the electrons are shared between the two, but not equally shared between the two. And this sign that's in here, we'll get to in just a second. Okay, so this is a polar covalent. That's what we're going to focus on here for a little bit. For example, here's hydrogen chloride, HCl. If you look up the electronegativity values for hydrogen and chlorine, you'll see that chlorine has a higher electronegativity value than hydrogen. Chlorine pulls electrons more closely, so we could add it up, and we'd find that it is, in fact, covalent, but chlorine pulls harder. So the kind of bond would be a polar covalent bond. So here is, using the sign system, hydrogen becomes partially positive, it says here, kind of, I like to say it. So it's kind of positive on this side and kind of negative on this side, because the electronegativity is higher for chlorine than for hydrogen. It pulls electrons to it more. It becomes partially negative, and the other becomes partially positive. It actually is the lowercase Greek letter delta. You may remember delta means change, and so it's changed to kind of positive and changed to kind of negative. Okay, we'll pick up here and we'll look at some other examples of polar covalent bonds and how they affect the behavior of molecules in the next video.